So, by show of hands, how many folks here use Docker or Kubernetes on a fairly regular basis? Perfect. So, most of the folks here, as you know, in the last, I'd say 3 to 5 years, we've seen it become pretty much the dominant way that custom software is being deployed across companies, right? And how many folks here, just by another show of hands, are running, say, security benchmarking tools against your cluster? I see some hands. Cool, good. How many folks are running pen tests against their cluster? Oh, a couple. Nice. And how many folks are uh, obviously probably scanning for CVEs, right? Yeah, so good things. Good. What about actively monitoring applications for suspicious behavior? Attempting to escalate privileges, or it seems to me, okay. Maybe your antivirus. Maybe there's antivirus on the node level, right? Um, when you walk away from here, my goal is that you'd have a plan for how you could actually go about doing all of those things. There's a lot of tools out there that you can use. I'm going to be demonstrating one called Minesweeper, which my team developed, which really just orchestrates it for you. But every one of these tools is open source, and I run a consulting group, and we specialize in Kubernetes and Kubernetes security. And almost everywhere I've gone, and we're talking Fortune 500 companies down to startups, isn't doing the things they should be doing. And Kubernetes is pretty new, so I think it's defensible. But there's a lot of great tools out there. So I hope you'll take this home with you and make your organization more secure. I've been using Kubernetes pretty much since it was around. I was on teams early on at companies that were trialing it, so I've used it a long time. Um, I had I've done the CK and CKS training. Actually, that's part of what inspired the tool was we recognized there's all of these great tools. We had implemented Aqua Security for a customer, and it was hard to implement and quite expensive. It's a good product, but it was expensive. But we realized there were all of these free tools that were being made by the same people who make paid tools, but they were open source and they were expensive. So we said let's make it really easy to use all of these tools. All right, so there's a few things we're going to cover. We're going to look at it in 4 phases. The Cloud Native Foundation thinks about this, thinks about cloud security in terms of our Kubernetes security in terms of 4 layers. So you've got cloud, cluster, container, code. Most of our discussion will be the bottom 3 layers. The cloud layer is more of your traditional role-based access control, two-factor auth, all of that. But we're going to be looking at the Kubernetes cluster. So how do you make sure the cluster itself is secured? We're going to be looking at the container. How do you make sure that containers have limited privileges and can't do bad things? And they're a little bit on code. So how do you make sure that the things that your code relies upon don't have obvious vulnerabilities? Although I will say we're not going to dig too deep into code. We're not going to be running SonarQube. That's kind of out of scope of this because that's not directly related to Kubernetes. Um, all right. So module 1, cloud. Um, I want to do a quick review of Kubernetes because I know not while you guys might be using it all, you might not be. Uh, it's going to help to think about the architecture once more, right? So if you remember go back to when you first used Kubernetes, right? You've got a number of nodes that run apps in Kubernetes, and then there's this thing called the Kubernetes API with various supporting services, database, etcd database, and things that basically keeps track of what should be running. And so when you deploy something to Kubernetes, you tell the API make it so, and then it creates a plan, and then ultimately the nodes have this thing called kubelet running on them that makes it so, that runs the app and tracks the app. When we think about securing the cluster, the main entry point for your cluster from the outside world is usually the API, right? And also the configuration of the kubelet and kube proxy. But the API is the most important part to secure your cluster. Um, there's a few general best practices, right? So you don't want to expose it on the internet, obviously. Put it behind a VPN, even IP whitelisting, something that makes it so somebody can't just be scanning the internet and finding your API. Uh, you don't want to make everybody an administrator. This is actually kind of a big deal. A lot of companies we're seeing are actually just giving everybody admin privileges, even developers who are intern level, and so they can very easily delete things in production, or if there's a phishing attack or something, become much easier for someone to break in. And the underlying database, if we go back here for Kubernetes, is that etcd data store. So you have to think about securing that as well, right? So making sure that wherever you're storing that or whatever backup solution you're using, that is not easily accessible because ultimately, if someone gained access to that, they could bypass everything and just write to that store, um, effectively deploying things. All right. So when you deploy the cluster, one common mistake. Let me see. Yep. Okay. One common mistake is not enabling role-based access control. So we're going to talk a little bit about that. Um, in a cluster, you can create different roles, and ultimately, a user, however they authenticate with that cluster, they're given a set of roles, and then those roles grant them privileges. So a little review: you're going to want to make sure you set up cluster roles and limit the access. If there's any applications that are going to communicate with your cluster, you create service accounts. So if you've ever written an application that can trigger a job dynamically, it uses a service account. So take an audit, take an inventory of your roles. This is one that a lot of automated tools can't scan for you, because really it's up to you to decide how much access someone should get. Kubernetes does come with a couple of default roles that are reasonable. There's like basically a read-write role called admin, and then a read role. That's a reasonable starting point, right? Give most of your devs read access to higher level clusters. Um, Maybe even not that, depending on your regulatory requirements. Maybe read, write, and dev. I don't know. Figure it out, right? But it doesn't have to be too crazy. Um, as with anything in Kubernetes, a role looks kind of like this. You guys have used Kubernetes, but notice the verbs, right, and the resources. Um, it's not rocket science. You're going to have to think through what level of access should your application or your users get, and give them limited access. Keep in mind that the default Kubernetes reader one might be giving people secret access. So you might want to edit that and say, well, maybe a reader doesn't need to have access to secrets in production because maybe you've got database credentials or things that would allow someone to move horizontally. And ultimately you bind it to a role. All right, so now you can, if you were to go, if you were to go online and you searched for Kubernetes security best practices, you would find that the Center for Internet Security has a set of best practices. It's a huge list. It's like 100 items, right? And if you were to go and try to implement all of those items yourself or check them all, it would take you hours, days, weeks. It would take a long time. And so luckily there are tools out there that can alert you to best practices and help you do a good job. So there's two that I want you to take home with you to look at using. These are not the only ones. There are a ton of other tools. But the reason I like these is that um, they are free and open source, and they are the Cube Bench actually follows the Center for Internet Security's benchmarks, which are very reasonable. And so it's a reputable organization. There's only really two of them that are well maintained that implement the CIS benchmarks. You have Cube Bench, and you have the actual Center for Internet Security produces a paid product. So it's the only free. There are a couple other ones that say they do this, but they're not well maintained. So this is a well maintained one. The reason they're well maintained is that Aqua Security sells a paid product, and that they make money in the backside on this. They want to upsell you to their paid product. Cube Hunter is a pen testing tool. It has two modes, and we're going to look at the results here of this. It has a active and passive mode. In active mode, it will actually actively try to exploit vulnerabilities to escalate its privileges. In passive mode, it simply boots up an application in Kubernetes and then tries to look around and see what it can do. So can it access the Kubernetes API? Can it see secrets? Can it, like if you deployed Kubernetes without role-based access control, it could connect to the API, it could start booting things up, right? So it's quite reasonable. It'll check and see if you have network policies or things. Can it reach out on the network? Can it see other pods on the network and can start connecting to them? Right? Very reasonable. We're going to demo them. Now, they're both ultimately command line utilities, and you have the ability to run them yourself. I've already run them because this isn't that long of a session. The output that they produce is either this kind of like plain text file. They have a web page output, and they have a JSON output. And so what we did for Minesweeper was we said, well, let's make it really easy for people. So this is a Minesweeper tool we built, and it has a Cube Bench and Cube Hunter integrated. And we made it so that you can just pick what kind of cloud vendor you have, or there's a generic one, and then it will generate a Helm install that allows you to run to basically run the scan. Has a little. It'll also upload the results of that scan back to your Minesweeper install, and uses an API key and stuff, so it's fairly secure. This is our test environment. So, and so you can run this. I invite you to do it on your cluster. What we do is we take that, it kicks it up to us, and we give you this nice little UI. This is just the data that it outputs anyways, but it's handy. We recommend setting it up as a cron job. So you could schedule it as a scheduled job in Kubernetes that would run, say, every day or once a week and give you an updated list. So if there's changes happening to the cluster, and you have a security regression, you'd know, right? So quite nifty. And you can see that we're running in Azure, and Azure does a pretty good job out of box. I think we largely took the defaults. So not bad, Azure. Good job, Microsoft. Kube Hunter is the other one. Same basic architecture. You run a Helm command, it boots up a pod in the cluster and scans things. And in the output, we grab that and give you that here. So you can see here, it tries to look around, and it did find a couple of things. By default, Azure exposes some metadata, which is not ideal because theoretically, if somebody knew what version of Kubernetes you were running, right, or what other versions of things are out there, it could theoretically make it a lot easier for them to figure out how they would exploit those things, right? So if they were using, say, Metasploit, there are a variety of ways where if you know the Kubernetes version and it's out of date, which a lot of people are running out of date Kubernetes, you could very easily exploit any number of vulnerabilities in historical versions of Kubernetes. So Azure did okay, but they've got one high, and down below they've got several. So, so you can see here the recommendation in this case would be to change your configuration in your cluster. You'll notice they give you instructions on kind of how you'd fix it. Kubebench gives you literally the CLI commands to fix it. Kube Hunter just gives you the general idea of the issue. And once you know the issue, you can Google it and figure out how to patch it, or maybe you don't. But it's good to know. If if you're doing like a SOC audit or something, certainly this output could be something you would provide back to the auditor, showing that you're compliant, with the Center for Internet Security's benchmarks, and that you've run a pen test. It's a very common requirement that you're going to have to get through with the SOC 2 audit is a pen test. Well, now you can do a pen test, and it's really easy. It takes literally 5 minutes. All right, let's head back. Container. So that was cloud security. Now you guys know how to secure a Kubernetes cluster, but what about the container? So let's just do a quick review of what a container is. I think you guys know, right? A virtual machine lets you virtualize a whole operating system inside of another machine, potentially many layers deep. And a container is different in the sense that your apps actually run in the same operating system. But wait, you say, whenever I boot up my app seems like it's its own thing, right? Well, containers leverage several features of the Linux kernel, and you do need to know a little bit about what these are, because otherwise, when we look at some ways of securing containers, you won't understand, well, why am I doing this? It uses C groups to limit the CPU and memory. It uses chroot to basically create a virtual file system. So what's actually happening is in the parent VM or operating system it's running in, there's a folder in Docker. There's a certain spot. It's different for containerd, whatever you're using. It creates a folder for each container that's running, and it unzips effectively the tar files from the container images and starts your app. But then before it starts your app, that Linux process changes to the root directory of that folder. So your app kind of tricks the Linux operating system into thinking it's like a new operating system, but it's not. It's actually it's sharing the same kernel as all the other containers running on that virtual machine, which is important, right? Because that means that if the app could break out of its location, it could start doing bad things. And then it uses namespaces to do things like make it so that every process ID has its own number, and it does some IP tables namespacing magic too. But that's taken care of for you by the container runtime. I want you to really think about the chroot there, because if you ever want to break out of a container, you do one of two things. You use chroot to change out of the folder you're in, or you mount the root folder of the file system into a subfolder, and you chroot to that subfolder. But using chroot, which is ultimately a kernel request, allows you to break out of a container. If you need more isolation than what comes with Kubernetes or containers in general, there's a couple of tools I want you to think about. One of them is called Kata containers. It's a wrapper that basically boots up virtual machines for each container. So it provides an additional layer of segregation. So even if, like for example, I think there was that vulnerability not too long ago where if you issued the right formed command in Linux, you could actually escalate your privileges to root. It was a bug in the Linux kernel itself. And so the only way to prevent that bug, when that bug existed, would have been using something like Kata containers or gvisor. So if you really want to protect yourself, one of these two methods works. Gvisor is a little different than Kata. So Kata containers create separate virtual machines for each container, which has quite a bit of overhead, right? Gvisor solves the problem a little bit differently. gvisor basically installs a Linux kernel plugin that will watch every kernel command, kernel request being done, and it checks the kernel's work and will block suspicious looking things. So if something tries to chroot, and even if there was a bug in the Linux kernel, gvisor would fix it, and it's gvisor because Google made it. Great products. gvisor is pretty easy to install and doesn't add a lot of overhead. So gvisor is one way to give yourself a lot of protection without a lot of overhead. Yeah, and when you think about a container, right, there's several pieces. I'm not going to go over this. You guys probably already know this. Ultimately, every layer of your container image gets unzipped into a folder, and then it boots up the application. All right, so preventing container breakout. So, and there's a tool I'm going to show you in a minute that can actually audit your pods running in your cluster and tell you if you're doing it wrong, basically. To prevent container breakout, we have to make sure that our application is running as a user that doesn't have escalated privileges. So you'll see here in this example, Kubernetes has this concept of a security context. This says what user ID your application should run with, what group it should run with. Remember, it's just a Linux process in the host operating system. So what user and group should it run with? And if any volumes are mounted, what user ID those volumes should be mounted as. Usually you set the FS group and the run as user group to the same because you usually want to read and write from the volumes that you mount. So that's really good. And then down below, you see there's several different ways to check your work. So like run as non-root, for example, if somehow you didn't have security context at top setting the user ID, run as non-root would check your work. Privileged also is a variation of that additionally forces it to not have additional privileges. And allow privilege escalation prevents the set UID trick, which would allow you to break out of a container. This is a little known feature of Linux, but certain commands in Linux, whenever you run that command, it magically changes to run that command as whatever user is the owner of that file. There's actually a bit on every file in Linux called the set GUID bit or whatever, and it lets you escalate. So ping, for example, uses that feature because ping has to escalate privileges. If you've ever used Kubernetes, you probably have noticed ping doesn't work. That's why it doesn't work. And this allow privilege escalation tells a Linux kernel if it ever issues the command to break out or to escalate privileges, block it. So it's just all these layers, right? And I do want to mention one other thing here. Just reiterating, you want to make sure that you don't ever mount host paths from the virtual machine it's running in. Or if you do, you need to be very careful to make sure you're not accidentally mounting a folder that potentially, is the root folder. Like if somebody, for example, could deploy a pod and you don't have any kind of policy management, theoretically, somebody who has access, if they've broken in to a container, they might be able to leverage, say, the service account on that container to do something bad, to deploy another pod that has escalated privileges. But we'll talk later about how you prevent that. We use policy management for that. There's a great tool. Let's see. Yeah, here, let me show you the tool called kubesec, which we built in. You can run this from the command line. It also has an API. We run it as a sidecar, and you can pick any app. I'm going to pick one that I know is going to have, yeah, here we go, Project Falco. Project Falco we'll cover later, but it has to run as root. It's the tool that actively monitors apps in Kubernetes. The Project Falco runs as root, so it has too many privileges. And you can see here, it does a whole battery of tests and it rates how bad a failure is or how good a success is. So you'll see here, it says you're running it as privileged and you're mounting the Docker socket. So they're saying, don't do that. And like we covered, if you did those things, if you could get code running in that container, you could break out and invade the host virtual machine and move across and see all the container's data. It's got a variety of other advice points, all good things. This is a review of the Linux kernel called process. You probably heard me talking about the Linux kernel. So every time your application wants to do something other than just simple code, maybe opening a file, opening a network connection, changing directories, changing the system clock time, it issues what's called a kernel call. So there's a C library that they use to do that. And your application operates in user space, meaning it's not root, it has limited privileges, and it makes a connection to that kernel to make that call. And there are tools that can actually intercept that. I mentioned gvisor earlier, right? There's a couple other ones that give you more sophisticated. I don't think we're not going to demo all of them, but I do want to mention them. More sophisticated controls. SecComp and AppArmor are two of them. Um, Essentially, what you do is you write up a policy in the language that AppArmor or SecComp uses, and then when you deploy the pod, there's a way to say I want to use the AppArmor profile of X. AppArmor is really neat because you can actually train it by watching an application for days or weeks, seeing what Linux kernel privileges it's using, and then you can create a profile off of that. So AppArmor is kind of where the industry is going, and I'm not going to demo every tool here, but I do recommend you think about it if you really want to lock it down. Um, yeah, and here's an example. You can also, on the Kubernetes pod itself, list off Linux kernel privileges that the app should have explicitly. So you can add or remove capabilities. The default capabilities in Kubernetes are fairly limited. It can open network connections and files, and that's it, basically. I'd invite you to dig deeper if you care, but you can add additional ones. So if for some strange reason I wanted to allow my application to change the system time, which is shared, by the way, because it's a virtual machine level setting, not a per pod setting. If I was to allow them to change the virtual machine system time, this is how I do it. I'd add this system time capability. I probably should never do this, but if I did want to, that's how I do it. We demonstrated kubesec a moment ago. Very handy. Now, there was a feature called pod security policies, and that feature got deprecated and replaced with pod security standards. So this is a very easy way. You should do this in your cluster to make it so that all the applications in a certain namespace in Kubernetes can't be run privileged. So Kubernetes now ships with 3 standards, and it's very easy to enable these standards for a particular namespace. I recommend you do this on every namespace where you're deploying applications that are not cluster system components. And there's 3 levels: privileged, baseline, and restricted. At a minimum, you should do baseline, which is the default. You should really do restricted, which would make it so that it forces every pod to explicitly specify that it can't run as root, that it can't run as privileged, and the user ID and group ID that it runs with. It's not hard for you to instrument this, and if you just simply toggle on pod security admission rule restricted on all of your user clusters, you will find that about 85-90% of your container breakout is eliminated. The host volume is the only exception, which we'll talk later how to prevent that. And yeah, you just add a label on a pod, excuse me, on a namespace like this: pod security enforce restricted. So very nifty. Yep, we're gonna. All right, network policies. This is another one. So network policies are a way for you to enforce firewall rules. So think like zero trust. Like if you use zero trust for virtual machines, Kubernetes uses network policies to do the same thing. Just by show of hands, how many folks out there are setting network policies in Kubernetes right now? I see a few. It's heavily recommended that you set up network policies. Here's an example one. In a network policy, you target a particular namespace. You can also do a pod selector. This one's just by the default one is everything in the namespace. But you can also target a specific app, particular label, whatever you want to do. And you just simply specify what are the ingress rules and what are the egress rules, or one or the other. A very reasonable one, let's see if I got, here. You can see some examples here. A very reasonable one that I recommend setting up is one in which you would allow everything within the namespace to talk to itself and everything outside of the namespace to be isolated. So you can't go across namespaces unless you create another policy explicitly granting it. It's a very reasonable policy. It works 90% of the time. And in the rare case that apps need to talk across namespaces, you can just open that up. If you need to refer to things like a database server with a host name and not an IP address, you're going to want to use something like Istio egress proxies. Istio CNI supports that, but that's not built into Kubernetes by default. Yep. All right, let's talk about policies. So I told you earlier you don't want to allow host paths because host paths allow applications to potentially break out, right? If a developer deployed an application and they mounted in the root of the parent operating system, effectively they have access then to all the files in the operating system. Not good. So we use OPA and Gatekeeper. There's also another very popular tool I've been reminded repeatedly, called Kyverno, which is very popular, and I'm sure there's others too. OPA is a language that allows you to describe rules. It's written in a language called Rego, or you write your rules in Rego, which are super esoteric and confusing. And so, what I've seen most people do is use the standard set that Gatekeeper provides. Gatekeeper is a tool that will sit and listen for any new deployments of anything in Kubernetes. And when it sees that happen, it can call a Rego policy that you specify. And if it's not allowed, it can block it, or it can just keep track of which ones are in violation. That's kind of an active and passive mode. We're going to take a look at what we did for Gatekeeper. So we recognized that you needed a policy management solution. At the time when we did this, Gatekeeper was the predominant tool of choice. In Gatekeeper, you create constraint templates and constraints. Constraint templates are Rego code files, which can contain one or more configuration options. So for example, you might say, I'm going to allow host paths in this namespace, starting with a certain folder, but not in that namespace. And so you create a constraint for host paths, or a constraint template for host paths, and then a constraint for each namespace, enforcing whatever rules are appropriate. We created a UI on top of that to make it easy for you to analyze what you have deployed or to deploy it all from scratch. So if you don't have any policies now, you could install this and walk through and probably set up all of your policies in a matter of minutes. There are a number of built-in policies. You have the pod security policy and the general ones. These are just from the Gatekeeper project itself, and we extended it to have some lifecycle management rules and things where you can add exceptions for certain teams for certain periods of time. But at the end of the day, there's a lot of very reasonable ones. You can see here, there's some here like host file system where you can limit the mounting of paths from the host operating system. Another one that's popular is limiting which repositories someone is allowed to deploy from. So if somebody can't pull from Docker Hub, maybe they can only pull from your own container registry. We got this nice little UI here that makes it really easy for you to set it up. We also read the spec and provide a interface dynamically for whatever that particular constraint template allows. So in this case, you can have an array of repositories that are allowed, and it just generates this UI for you, and it's very easy. I will say for most enterprise clusters, you might set up your dev environment with this, and then you probably should pull whatever that configuration out into a pipeline and be deploying it to higher environments through a CI/CD pipeline, because I'm a big fan of policy as code. But I have found that a lot of companies aren't using this tool, and so we wanted to make it easy and accessible so that people could set this up who maybe don't have time to do that or are in a hurry. All right. So, code. Let me back up. Who here knows what a CVE is? Anybody get excited about CVEs? We've probably all been told a million times by our company that we have to eliminate CVEs, common variables, common, now I'm going to blank on the name, common vulnerabilities, totally blanking on it. Anyways, CVEs are known vulnerabilities that exist. The government and several security organizations keep track of vulnerabilities that security researchers have found. And there's a number of great tools where you can just simply throw it at a container image and it'll kick back a list of every vulnerability that exists. Known vulnerability. Not vulnerabilities in your code, but in the libraries you use. For example, I heard another speaker earlier today saying if you're using Electron, you're pulling in 87 dependencies or something, right? Any one of those could have a critical vulnerability. And if you're developing in any modern framework, think Spring Boot is a big one. You're pulling in a lot of dependencies that may or may not be secure. And so one great scanner is called Trivy. I'm going to show you, we built that in. There's two other ones that I see used a lot, Snike and Twistlock, and there are others. But Trivy, Snike, and Twistlock are all maintained by major companies that aren't going anywhere. They're Kubernetes security SaaS companies, and so I recommend sticking to those simply because if you pick one of the less popular ones, the project will probably be abandoned. There's also another one I want to mention called Anchor that is very popular in the government realm because they've gone through some work getting compliance certificates and things. We wrapped it so we can run and scan images with Trivy. Let's take a look at what's happening here. So this is a kube proxy, which is part of that Kubernetes cluster. This is Azure's version of it. And you can see, in this case, we're running Kubernetes 1.19, which is a bit outdated, but it's a test environment. And you can see here the scan result, and it's not great. We have a number of criticals. So we should probably update our Kubernetes cluster, right? I have to make sure that I have a cluster that's not secure so I can demonstrate this. And if it's fixable, it'll tell you here literally what version to update to. So super neat. The big three scanners I mentioned all have some kind of solution. They don't come with UIs and they don't orchestrate. We built out a UI for this. It'll scan everything running in Kubernetes clusters. You can run it in a pipeline. And you can block any application from booting up that doesn't meet your requirements, as well as set up exceptions and communicate about those exceptions on the platform. And last but not least, Project Falco. So the one question that I think nobody really raised their hand on was whether you're actively monitoring applications for doing potentially bad things, like trying to break out of the container. Most of you probably aren't doing it. It's hard right now, because right now you just get a log file out of a tool, out of Project Falco. What Falco does is you run it on every node. It hooks into the Linux kernel. It's aware of Kubernetes though, so whenever it sees something suspicious, it knows, oh, that process is part of this pod, and it drops out a nice friendly log file telling you what the issue is. What I realized though was that there wasn't really a good tool for orchestrating this, so nobody was using it. It's a really cool tool, but you need something to bubble those things up and alert people. So we built out a UI here where it'll automatically group together the same one. Let me pick one that's more serious. Here we go. All right. So it'll group together based upon a hash all of the alerts that are for the same issue, and then you can see all the related events, as well as it gives you kind of a UI of the incidence rate. Obviously, you can see here it's a very consistent error, probably triggered by some batch activity. And we have had this issue for weeks in this environment. So it's an old version of Prometheus. You can see it's trying to access the file it doesn't have access to, which is strange, not good. That would be, if you had a lot of this kind of behavior in an environment, you might dismiss it, or you might say, well, there's something wrong here. This application's trying to do something it's not supposed to. We also have it send out email alerts whenever it's, you can see here the raw log that it kicks out, and then we parse it into a nice little event here. If this was to happen in a real environment, you'd want to get an email or something about it. So we have some grouping where the first time something is detected within a time period you define, like a 30-day period, it'll email you and say, oh, something's doing bad stuff. And then you can go in and figure out what you want to do about it, as well as a number of useful reports. All right, so we've covered the 4 C's of cloud native security: cloud, cluster, container, and code. We've done labs where we've looked at each of these applications and the kinds of output that they can generate and how you can deal with them. And just about done. I do want to mention, if you want a copy of this presentation, I saw a lot of people taking photos as I was going through. You can go to the website, minesweeper.io. And if you go to the blog, you'll see I have posts about some of the conferences we're speaking at, as well as a copy of this presentation, as well as a longer one that goes in more depth, and a lab guide that literally you could, if you have Docker on your local machine, you can boot up a Kubernetes cluster with Minikube and run through the lab guide, and it walks you through setting everything up. It installs in about 5 minutes, depending on your internet connection speed. So nifty. So we've covered the basics, right? I hope that you've got some take home, some things you can do to make it better. Kubernetes security is important, but Kubernetes is new. So yeah, I hope you've enjoyed it. At this point, I can open it up to questions. You can play Stump the Chump, see if you can stump me.